Modern AI video production is defined by friction. Creators generate a script, design a character, and animate it. When human operators manually shuffle data between these isolated systems, they force them together through sheer repetitive effort, creating massive bottlenecks. Every time a creator copies text from a script generator, reformats it for a video model, and aligns the output in a lip-sync tool, they incur a severe time penalty. The software is fast, but the human routing is slow. Consider the metrics required for commercial viability. In a recent production case study, a creator delivered a highly consistent 3-episode realistic short drama from initial concept to final export in less than 40 hours. Running a traditional linear multi-tool workflow makes that timeline mathematically impossible. Typing individual prompts, evaluating hundreds of clips, and manually editing the timeline requires days of human labor just to reach the first rough cut. Reaching a 70 to 80% reduction in total production time requires a structural shift. The solution requires abandoning the practice of mastering individual generative tools and instead deploying an AI agent to act as the central orchestrator. In this context, an AI agent does not generate the video. The agent operates strictly as the brain of the operation, a central routing matrix. This central node automatically selects the correct tool. It pulls a script and translates it into visual parameters, bridging systems seamlessly. By handling translation, the agent bypasses manual user input for prompt generation. Repetitive data entry is completely automated. To understand exactly how this architecture functions, we need to map the precise 8-stage agent workflow from the initial concept to the final export, while establishing the strict quality control checkpoints required to keep it on track. The value of this matrix is clear. It removes syntax translation and copy-pasting from the operator, freeing the human entirely for high-level creative evaluation and narrative decisions. This horizontal timeline maps the complete 8-stage production architecture. The first stage activates when the foundational idea moves into scripting. The agent pulls the core concept and interfaces directly with large language models. By routing the idea into Claude 4, DeepSeek, or Kimi, it generates the structural script and scene beats. At this point, the pipeline hits its first major bottleneck. Generating individual shots from a script is easy. Maintaining tight character consistency across 30 different video clips is incredibly difficult. If you skip character reference generation, you lose visual continuity immediately. You end up with a highly detailed face rapidly morphing through different ages, ethnicities, and lighting conditions before it locks into a single, usable identity. To prevent this degradation, the agent enforces a strict countermeasure. It mandates the creation of reusable character and style reference packs before authorizing any video generation. The agent takes the character descriptions from the generated script and routes them into tools like Instant ID, paired with Kling or Seedance. This locks in the baseline visual truth for the entire project. Strong scripts and rigidly defined character parameters form the bedrock of the workflow. Downstream animation models cannot fix upstream continuity failures. With the visual baseline established, the pipeline advances. The storyboard and video generation nodes come online. Pushing data into modern video models like Kling 3.0, Seedance 2.0, or Hailu requires highly specialized inputs. These engines do not respond well to conversational text. They require rigid, mechanistic parameter syntax. The agent acts as the translator. It parses the human-read script and storyboard descriptions, rewriting them into optimized, model-specific prompts designed to yield the exact camera movement and subject action needed. The agent then combines these optimized prompts with the locked character reference packs, dropping a complete data payload directly into the chosen video generation model. During the heavy compute phase, the agent manages the queuing, organizing the resulting raw video clips into sequential folders mapped directly to the script. Automating the syntax translation ensures high fidelity across the project. It removes the need for the human operator to sit and manually write, tweak, and test hundreds of individual camera prompts. The video generation phase consumes massive computing time. To compress the overall schedule, the workflow utilizes parallel processing. While video models render, the agent simultaneously routes the script's dialogue to audio synthesis engines like ElevenLabs, Fish Audio, or Minimax. Concurrently, it feeds emotional and pacing cues into models like Suno V4 or Minimax Music to generate the background score and atmospheric tracks. The convergence point happens fast. The agent collects completed video clips, synthesized voiceover, and music tracks, braiding them together for the final assembly phase. These combined assets are routed directly into timeline-based post-production software, typically CapCut Pro, for structural editing and pacing alignment. The critical final polish occurs here. The finished timeline is processed through Live Portrait to enforce precise lip sync, mathematically aligning the synthesized audio tracks with the generated video characters. Treating audio, score, and visual generation as simultaneous streams rather than sequential steps is what allows a 40-hour project timeline to actually work. An autonomous workflow running at this speed will quickly degrade without structural boundaries. Look at the red gate icons positioned strictly between every major production node. The most common point of failure in AI video production is over-relying on the agent's autonomy. Letting the machine run from script to final export without intervention guarantees a compromised final product. This starts with the initial commands. Vague or poorly designed instructions directed at the agent itself result in inaccurate parameter translations, which cascade into massive visual errors downstream. These gates represent mandatory quality checkpoints. The workflow must physically pause after generating key deliverables, like character designs or the final script. Only when a human operator inputs approval does the system advance. Maintaining strict quality control is especially vital during the final post-production and lip sync phases, where the operator must scan the footage for AI hallucinations, texture warping, or synchronization glitches. The pipeline is designed strictly for execution. The human operator must entirely own the roles of subjective evaluation and course correction. Delivering a highly consistent multi-episode drama in under 40 hours isn't magic. That speed is a direct result of strictly adhering to standard operating procedures. Rule 1. Always review the agent's output before allowing the data to advance to the next stage. A bad script guarantees bad video. Rule 2. Systematically build and label your visual data. Constructing reusable character and style reference packs for every project is the only way to ensure scene-to-scene continuity. Rule 3. Build modularly. Combine multiple, highly specialized tools tailored to specific tasks, rather than relying on a single monolithic software suite to handle everything from text to lip sync. True production speed does not come from pushing generative models to render faster. It comes from the rigid, systematic organization of a multi-tool architecture. The utility of an AI workflow lies in orchestration and data routing. Generating an image or a line of text is a commodity. Aligning 100 distinct outputs into a cohesive narrative is an engineering challenge. Adopting the specific software stack available right now is far less important than mastering the underlying node-based structure. Tools will evolve, but perfectly synchronized data routing will remain constant. AI provides the raw processing power to drastically reduce production timelines, but it completely lacks subjective taste. Human quality control at every distinct checkpoint is the sole variable that determines the professional caliber of the final export. By operating as the architect of the pipeline and delegating the rote execution to the agent, creators can reach massive production scale without sacrificing their final creative vision.